Hello everyone, welcome back to Nated Engineering. We are still on friction, engineering science and 3. And today I want us to look at a question which is a question from the question paper that was written on the 30th of November 2015. It's question number 4 and it reads as follows. 4.1 they say give 4 applications of friction in the engineering industry. One example, the first example will be the transfer of power using belt drive, the bringing linear, okay, let me read from the name. They say bringing linear and rotational movement to halt, drilling, cutting of materials, clamping of workpiece in attachments and jigs, clamping of workpiece in vise and chuck. Yeah, those are the examples. I don't want to dwell too much on this because I want us to focus on the calculations, and I'm sure you do have these things in your textbooks. So we're going straight to 4.2. 4.2, they are giving us a scenario. The weight of an object is 4 tons and it rests on an incline of 30 degrees to the horizontal. The coefficient of friction is 0.6 for the surface. And then the calculations. Calculate the following. 4.2.1. The force required to pull the object upward against the slope if the pulling force forms an angle of 20 degrees with the incline. 4.2.2. The force required to push the object downwards along the slope if the pushing force forms an angle of 25 with the incline. So we're going to start with 4.2.1. They are giving us this scenario where we are having an object of mass 4 tons, which we know it's equals to 4,000 kg. They are saying the coefficient of friction is 0.6, and then they are saying the incline, the slope is 30 degrees. They are now saying a force is pulling this block upward, and that force makes an angle of 20 degrees with the incline. They are basically telling us that this force is being applied at an angle, and the angle is 20 degrees. And we know that whenever we are having a force that is being applied at an angle, it will form 2 components. That one we already know. The components will be the component that is perpendicular to the surface that we are dealing with, which will be the inclined, and the one that is parallel to the surface. Therefore, we are going to say, using trig ratios, we are going to get the horizontal component as F cos alpha, and then the vertical component as F sin alpha. And then we know normal reaction, we know there will be mg sin theta going downward, which is always in that direction. And then there will be frictional force going downward. Why? Because the object is moving upward. We know frictional force always opposes motion. We are having what? Mg cos theta, which will be the component of mg. And this basically our structure is complete. And then from there we have to get formulas from the structure for us to be able to do calculations, because what we are interested in is F. We are asked to calculate F, which is the force that is being applied here. I'm going to equate the forces that are acting parallel to the surface, which will be F cos alpha. F cos alpha is the one that is going upward. These are the directions of the components. It will be equals to, you can tell that it's the only one that it's going in that direction. mg sine theta and the frictional force are going in the same direction. Therefore, it will be mg sine theta plus frictional force. Looking at this, we are looking for this cos we have the angle which is alpha as 20 degrees. We have m, we have j. Sine theta, we have theta. The only thing that we do not have from this equation is this one, which is the frictional force. Therefore, now we have to get the frictional force. We know that the frictional force, it's equals to normal reaction times the coefficient of friction. The coefficient of friction we do have as 0.6. We now have to get the normal reaction. How are we going to get the normal reaction? To get the normal reaction, we are going to equate forces going, the forces that are perpendicular to the surface that we are dealing with. We're going to say forces going upward, which will be normal reaction, and this vertical component, it will be normal reaction plus f sine alpha. It's equals to this component, which is mg cos theta. Because we want normal reaction, we are going to make it the subject of the formula. Normal reaction is equals to mg cos theta minus f sine alpha. From here, we can go ahead and remove this diagram. I have everything that I need, and I trust that you have copied this diagram down so that you can make references as we proceed. But me personally, I know that I have everything that I need from the diagram. Therefore, from here we are going to say we have normal reaction, meaning our frictional force is equals to what? Mu times, open bracket, we put this, mg cos theta minus f sine alpha. This I can now remove. Actually, I can remove all of this because now I have the frictional force, which is what I needed to put here. So I am going to get rid of this. We are having these two equations now. We have everything here. We are looking for this. We have everything except for this. So in the place of this, we are going to put, and then we're going to have f cos theta is equals to mg sine, is f cos alpha, not theta, mg sine theta plus mu in bracket mg cos theta minus f sine alpha. And then from here, I'm going to open the bracket, which will give me a formula like this: f cos alpha is equals to mg sine theta plus mu mg cos theta minus mu f sine alpha. I opened the bracket. Now what I want to do is to group like terms, because I can see that I'm looking for f. Remember, I have f here, I have f here, so I'm trying to get these two terms in like the same side of the equal sign, so that I can take f as a common factor, which is what I am going to do. F cos alpha, it's going to be positive, mu f sine alpha is equals to mg sine theta plus mu mg cos theta. So what I'm going to do is take f as the common factor here. We are going to have f in bracket cos alpha plus mu sine alpha being equals to mg sine theta plus mu mg cos theta. Let's create space. Get rid of this and take this up. Now we have this. We are going to divide both sides by cos alpha plus mu sine alpha, both sides. Sine alpha. This will cancel up this, and then we are going to have f being equals to mg. This is mg sine theta plus mu mg cos theta divided by cos alpha plus mu sine theta. And then from here we can just substitute and get the value of f. F is equals to, what's the value of m? 4000. G 9.8 times sine, what's the value of theta? 30 plus mu 0.6 times m 4000. Gravitational acceleration cos theta, it's cos 30. This is 30. Cos alpha, alpha is 20 plus mu is 0.6. Times sine alpha is 20. And then from here you punch this whole thing into a calculator and you are going to get an answer, which is what I got, at least, of 34910.257 newtons, which can be written as 34.910 kilo newtons. And this is how I prefer you do this calculation. I know maybe in the memo they might do it in another way, but I prefer you do everything like this and then substitute at the end of the calculation, at the end of at the end. So we are going to do 4.2.2. 4.2.2. The force required to push the object downward along the slope if the pushing force forms an angle of 25 with the incline. And then we go back to our diagram. Only now the force is not pulling the object upward. It's now pushing the object downwards. Remember, now we have to find the direction of the components. It's going towards the point, therefore the components are also going towards the point. We have normal reaction, we have mg cos theta, we have mg sin theta. We have the frictional force, it's in the opposite direction because this thing is traveling in that direction. We know frictional force always opposes motion. So we are going to, let's start by getting our components values, which will be f cos alpha, and this will be f sin alpha. And then we are going to focus first on the forces that are parallel to the plane that we are working with. We are going to say mg sin theta is going downward. F cos alpha is also going downward. Only the frictional force is going in that direction. Therefore, mg sin theta will be we'll say plus F cos alpha will be equals to the frictional force. Now we have everything here, as we know. The only thing that we do not have is F, which is what we are looking for. Now we have everything here except for F, what we are looking for. Remember, the main thing that we are doing here is to calculate for F. The only thing that we do not have here in this equation beside for F, which is the force, it's the frictional force. So we have to go and say frictional force, we know it's equals to what? Normal reaction times mu, the coefficient of friction. The coefficient of friction we are given. Normal reaction we do not have. But using this diagram we can get the formula to calculate for normal reaction. Normal reaction, we are now focusing on the forces that are acting perpendicular to the surface plane. Normal reaction is pointing up alone. The F sin alpha and the mg cos theta is pointing down. Therefore, it will be F sin alpha plus mg cos theta. And then from here, we can get rid of the diagram. Hopefully, you have the diagram drawn down. What do we do from here? Frictional force is equals to mu, open bracket, in the place of normal reaction we put this, F sin alpha plus mg cos theta. We can now get rid of this. So we are going to put this in the place of friction here. It will be mg sin theta plus F cos alpha. It's equals to mu times open bracket f sine alpha plus mg cos theta, close bracket. I want to open the bracket here. It will be mg sine theta plus f cos alpha is equals to mu f, what's going on, it's times f sine alpha plus mu times mg times cos theta, mg cos theta. Now we have to group like terms. We have f here, we have f here. Let's make sure that these two terms are on the same side of the equal sign. I'm going to say f cos alpha minus mu times f sine alpha is equals to mu mg cos theta minus mg sine theta. Then I get rid of this. Now let's take f common. F in bracket will be cos cos alpha minus mu sine alpha, close bracket, it's equals to mu times mg cos theta minus mg sine theta. And then we are going to divide both sides by this, which will give us a formula like this. F is equals to mu mg cos theta minus mg sine theta divided by cos alpha minus mu sine alpha. And then from here we substitute. F is equals to, what is the value of mu? Coefficient is 0.6 times m, which is 4,000. Gravitational acceleration 9.8. Cos theta is 30. Minus m is 4,000. Gravitational acceleration 9.8 sine 30. Theta is 30. Cos alpha is 25 minus 0.6, which is mu, sine 25, and this will give us our f as 117.9 0.90 newtons. And this, I feel, is the best way to do this calculation, where you just make sure that before you substitute, your force is the subject of the formula, so that when you are substituting, you only put the values once and punch on the calculator. Unlike some, maybe from your memo, if you have a memo, you will see that they start substituting early on your calculations, and they start rounding off up until they get to the answer. I feel like that is a bit confusing when we compare it to this. Unlike you do everything, it's better you do everything, and then once you are here, the only thing that you need to do is just substitute and get the final answer. And I feel like that is the best way to do it. It then will depend on how you see it, but this is the only way that I'm going to teach, because this is the way that I prefer. So as far as the question, as far as what we were required from the question, we are done. And you have to understand that knowing how to draw the structure or the diagram from the question that they gave you is the important part. Knowing again how to find the directions of your component, that is another point, because it will affect you if they are wrong directions on the signs, and once the signs are wrong, you are not going to get a correct answer. If I can compare this to the one that we did previous, let me get rid of this answer. If you still have the diagram that we did previously, you can notice that, let me change color. You can notice that F was equals to mu mg cos theta plus mg sin theta, and then it was cos alpha plus mu sin alpha. So if you get your directions wrong on the components, it will affect you here. And once your signs are wrong, then your answer unfortunately is not going to be correct. So you have to know how to get the direction of the components. You have to know how to draw the correct structure based on what they are giving you. And yeah, that is all I had for today, for this video. I will see you on the next one.